Adding and subtracting radical expressions. Math practice breakdown by Mr. Wardrick. In Virginia, the SOL Standards of Learning is 6.NS.3, page 44. If you go to Virginia Department of Education website, you find this link. Learning target. I will add and subtract radical expressions and know what to do when there's no coefficient. Success criteria. I know I'm successful when I can add radical expressions correctly with at least 80% accuracy out of 10 attempts. A radical expression has a radical. We grew up calling it a square root. A radicand is that number under the radical that may or may not have a square root already. Radical expressions can include coefficients. Coefficients are the whole numbers outside of the radical, not to be mistaken for the index. We're not even discussing index in this lesson. Let's stick to the basics. Rule number 1, when there's no coefficient, automatically add a 1. If you look in this example, you have 3 radical 7 plus radical 7. Although there's no coefficient in front of the second radical expression, the rule says to add a 1. In this next image, we'll break down that practice example. In this problem, you have a 3 radical 7 plus a 1 radical 7. Since the radicand, which is 7, is already the same, that remains the same for the answer. Then you take the coefficients. 3 plus 1, what gives you 4. Your answer is A, 4 radical 7. How to factor radical expressions. Factor all radicals that are not in their simplest form. In this example, 4 and 2 are factors of 8. The square root of 4 is 2. Remove the radical once the radicand that was simplified is in its simplest form, then multiply it against the coefficient. Next, add or subtract the coefficients. You have 6 minus 15, which gives you negative 9. Now let's try some practice. If radicands are not the same, factor them. Example 3, 18 factor is 9 and 2. And then when you find the square root of 9, you get 3 radical 2. In number 1, the radicands are the same. Just add the coefficients. For number 1, you get 8 radical 2. The next slide we will see will include the answer key. Oh, don't get too excited. We're still going to go back and show our work. Again, while looking at the answer key, don't think that this is a cheat code. This is just showing you the end result, only to go back to the beginning and work our way back to the end result. These next few slides, we'll look at each question. We'll even see some explanations of the answers and how we got there. But please make sure you're taking notes. So we're going to go over problems 1 through 9. As you can see, there's no 10. But stay tuned because 10 is in this presentation. Here are numbers 1 through 3 explained. You may want to pause your screen. All right, let's take a look at number 1. We have similar radicands. We just add the coefficients, 3 plus 5, giving us 8 radical 2. Wait a minute. We do not even have similar radicands in number 2, so it cannot be combined. You leave as is. Everything's in its simplest form. For number 3, you just factor out 18 and 8, and you end up with 5 radical 2. You may want to pause the screen to read the explanations for numbers 4 through 6 explained. You may want to pause the screen a third time to see numbers 7, 8, and 9 explained, but we're going to see how we did the work. Stay tuned. For number 4, you have 2 radicands that are the same. You add those 2 coefficients, and you get 7 radical 7. And then you bring down the 4 radical 3. 3 is already in its simplest form. That is your answer. For number 5, you take the coefficient 6 and you subtract it by 3, what gives you 3. Since you have the similar radicand 2, you bring that down. The other one, you don't have a coefficient in front of radical 2, so you add a 1. 3 plus 1 is 4. 4 radical 2 is your answer. For number 6, you take the radicands 50 and 8 and you factor those out into their simplest form, and eventually you end up taking the simplest form of the first radicand and multiplying it against the coefficient. You also do the same for number 7, where you have 27 and 12. You factor those out. That first radicand ends up being multiplied against the coefficient to find your new coefficient at the end. Same thing for number 8. You may want to pause the video just to see what's going on. All right, I want you to attempt number 9. You got it. You're on your way.
I'm on my way.
All right, now it's time for the exit ticket. Time to hit the door. Here's your number 10. I told you we wouldn't forget about the number 10. Oh, don't let the huge radicands discourage you. Just break them all down. How many quarters does it take to make 75? 3. So you take 25 radical 3. You got 4 radical 3, and you got 9 radical 3. When you combine all 3 using the operation that's there first, which is the minus sign, you get 25 minus 4, 21, plus the 9, and you have 30 radical 3 is your answer. Great job. Thanks for persevering through these 6 minutes. Keep it there.